Welcome to a brief history of AI. In this lesson, we'll journey through the evolution of artificial intelligence, from its early roots in the 1950s to the powerful systems that shape our world today. We'll explore breakthrough moments, pioneering researchers, and shifting waves of optimism and setbacks. By the end, you'll understand how each milestone propelled AI forward, and why it matters for our rapidly evolving future. Long before modern computers, philosophers questioned if machines could think. In the 1950s, Alan Turing's paper Computing Machinery and Intelligence posed the question, can machines do what we, as thinking entities, can do? This sparked new ways of thinking about intelligence as symbolic manipulation, eventually inspiring future researchers. Turing's ideas laid the groundwork for a discipline that would soon be called artificial intelligence. In 1956, John McCarthy convened the Dartmouth Conference, where AI officially took shape as a field. Researchers like Marvin Minsky, Claude Shannon, and Nathaniel Rochester explored thinking machines, coining the term artificial intelligence. This pivotal moment drew together brilliant minds, setting the stage for decades of exploration into how machines might emulate human thought. Early AI research focused on symbolic AI, or GOFAI, which modeled intelligence through symbols and rules. Programs like Logic Theorist and General Problem Solver tackled puzzles or proved theorems by applying logical operators to these symbols. This top-down approach assumed that, by encoding enough logical rules, machines could mirror human reasoning, a bold hypothesis that spurred many initial breakthroughs in AI labs worldwide. In the 1960s and 1970s, optimism about AI soared. Projects aimed to translate language in real time, diagnose medical conditions, and even mimic human thought processes. Funding flowed in as researchers envisioned human-level intelligence within decades. Expert systems like MySyn and XCon showed promise in medicine and finance, though real-world complexity later revealed the limits of these early approaches. As lofty goals failed to materialize, AI entered a winter during the mid-1970s and 1980s. Funding dried up, and public enthusiasm faded. Hardware limits and the challenges of scaling rule-based systems proved daunting. Despite the gloom, some researchers kept moving forward, focusing on the need for stronger computational resources and more robust data. These lessons would shape the next wave of AI. As disillusionment set in, researchers pivoted from rigid rule-based systems to machine learning, letting algorithms learn from examples. Decision trees, nearest neighbors, and basic neural networks flourished. The rise of personal computers made it easier to gather and process data, spurring fresh optimism. This bottom-up approach provided more flexibility. Instead of encoding every rule, you simply supplied sufficient examples and let the system uncover the patterns. In the late 1990s and early 2000s, the internet boom and cheaper computing resources fueled AI's revival. Massive datasets from online transactions and web content gave machine learning algorithms richer material to learn from. This surge in data and processing capacity opened the door for more ambitious experiments, setting the stage for the modern AI renaissance we see today. The 2010s heralded a deep learning revolution, leveraging multi-layer neural networks to achieve unprecedented accuracy. Landmark models like AlexNet in 2012 excelled at image classification, showcasing how stacked network layers capture complex features. With abundant data and high-performance hardware, companies like Google and Facebook quickly adopted these methods for speech, vision, and language. Deep learning shattered previous limits, bringing AI into mainstream applications. A watershed moment came in 1997 when IBM's Deep Blue bested chess grandmaster Garry Kasparov. Though reliant on brute force search rather than modern machine learning, it showcased a machine excelling at a strategic, human-dominated game. Deep Blue's victory hinted at computing power's potential in tackling complex tasks. It didn't spark an immediate AI revolution, but it opened public eyes to what machines could achieve. In 2016, Google DeepMind's AlphaGo startled experts by defeating Go master Lee Sedol. Unlike Deep Blue, AlphaGo combined reinforcement learning and deep neural networks to develop novel strategies. This victory proved machines could tackle open-ended, complex tasks once deemed unassailable. AlphaGo's success reshaped AI research trajectories, demonstrating that with enough data and self-play, systems can surpass even top-tier human expertise. By the 2010s, AI found its way into healthcare, finance, retail, and beyond. From detecting diseases in medical scans to powering recommendation systems on streaming platforms, AI grew indispensable. This widespread adoption hinged on data-driven insights and powerful algorithms, with cloud computing making it all scalable. As more organizations recognized AI's potential, the technology evolved from a research novelty into an everyday necessity. If you want to explore AI's trajectory or experiment with it yourself, online resources abound. Open-source frameworks like TensorFlow and PyTorch allow anyone to replicate seminal experiments in image recognition or NLP. These platforms offer a window into both AI's past achievements and cutting-edge innovations, ensuring the field remains accessible for enthusiasts and professionals alike. Let's recap. From Turing's Big Question and the Dartmouth Conference to AI winters, machine learning, and the modern deep learning boom, AI's path has been anything but straightforward. Each cycle of optimism and doubt led to new discoveries. Recognizing this history helps us appreciate how today's breakthroughs stand on decades of gradual progress, setting the stage for tomorrow's innovations. By knowing AI's roots, we see how past challenges inform future possibilities. Today, AI drives personalized medicine, automated customer service, and cutting-edge robotics. This historical perspective encourages a balanced outlook, awareness of hype cycles, ethical considerations, and the importance of data. As AI practitioners, recognizing where the field came from will guide us in shaping responsible, impactful technologies, ensuring that tomorrow's breakthroughs are grounded in lessons learned over decades.